Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson. We're going to talk about the importance or lack thereof of a PhD in reliability engineering.
Yeah, and this came up as a question I got. I got a woman, she sent me, Richello sent me a message saying, here's some ideas and thoughts for your podcast. And she went to Rams recently and came back having...
Yeah, I saw her there. Hi, Richello.
And talked to a bunch of people and enjoyed the conference and stuff and came back with even more questions. So I think right there was a good sign, in my opinion, that she doesn't need a PhD because she's already thinking like one. She's thinking.
Oh, yep.
There's that. And willing to ask questions and make observations and think through stuff and learn and so on. I think that's worth it, whether or not you have a degree. But you have a degree in reliability engineering and PhD. So
I have two technically, but
okay, all right, awesome.
A master's and a PhD. So
okay, but the question was pretty straightforward: is it worth getting? And I don't know whether she was thinking, or if other listeners are thinking about going back to school or continuing in school to get a PhD versus not. Now, one point of reference is my daughter she's still in school. She's been in school for a long time, is in a PhD program in chemistry. And I said, you already have a master's. Aren't you getting job offers and stuff like that? And he says, yeah, for a tech or a warehouse forklift driver type stuff. If you want to work in chemistry, do chemistry stuff, you pretty much are required to get a PhD in chemistry.
Yeah.
Otherwise, you're just a non-starter. And okay, well, that's the industry. I don't think Madame Curie had a PhD, but she did just fine. Yeah, my daughter laughed too at that one, but different times.
Yeah.
Yeah. So, what's your take on this? Because you've been on the other side.
Well, I mean, there are certain industries where you have to have a PhD if you want to be a chemist. I was about to say chemist, but if you wanted to, for example, work in the medical device industry, from what I can see, you need to have a PhD. And some of the reasons for that are pretty obvious. Working with a device which involve blood sample being mixed with chemicals to do certain things and then being pushed through a plastic container with little wells and things like that, where you had a PhD in microfluidics helping you out. You can see where that sort of very high level niche understanding of these topics were necessary to essentially come up with the next generation of medical devices. Mm-hmm. But if I had to have a one-word answer for reliability engineering, if you need to have a PhD in the world of reliability engineering, the answer is no. If my single-word answer, but if I had more time or a bigger word count, I'd say it would depend. If you want to if you're eyeing a job in a more regulatory setting or governmental organization, FDA, NRC, then a PhD is often very attractive in terms of getting your foot in the door, which is very different to me saying that you're going to be good at your job. Those are two very different things. But yeah, the simple answer is no, in my opinion. But it also depends on what it is you're trying to achieve.
Yeah, there's good and bad reliability engineers that I've met and worked with over the years that did and did not have PhDs. And mm-hmm. There's, you can be really, really specialized. And let's say it's just crack propagation, but you work in an industry that works with Jello, and cracking is a feature, not a defect. And so it's that expertise doesn't go anywhere in and of itself. The ability to ask questions and learn and to do all the other things that to do well in your job, independent of reliability. I think any job is a part of that. Is um, what I see in the way PhD programs run is they tend to specialize in, but I mean, then again, Chris, when we talk, we can talk about a whole range of huge topics. So somewhere along the line, you learned a broad spectrum of things across all kinds of stuff. And I don't think that was just in the PhD curriculum. I think that was a good hefty dose of curiosity and experience.
Yeah, I'm teaching a course right now, and one of the things I said at the start of the course, and I was sort of introducing myself and who I am and what I do, I said I got my PhD in reliability engineering, which meant I immediately knew I was awesome. I was a fantastic reliability engineer. And then 5 or so years later, then I started learning how to be a good reliability engineer. So, is the problem with PhD curriculums or curricula is that they're not practical. They just simply are not. Uh, there is no way anyone can convince me otherwise, knowing I've been part of that story and been worked at a university until I couldn't take it anymore. Mm-hmm. It's just not practical. It's not practically focused, at least in North America. In other countries, you have a lot more smaller universities partnering with certain industries where it's a lot more commercially orientated, and there are scenarios where it can be very helpful. Carl talks about a good story where University of Maryland's CALS department back in the day helped him out with some issues he was having with the doors of the vehicles he was working on. And they were able to come in and really look at the test regimes and essentially compress test durations down to an incredibly small period of time because they had a really good understanding of the physics of failure as part of their analysis. And that's a great story. That's what universities, I would argue, should be doing all the time.
Right.
But that's not what you're being taught as a PhD student. It's just not.
No. And that's part of when I was teaching at Maryland. They haven't invited me back this year yet, but they might wait until June, like they did the last couple of years. But when I was first teaching it, they first invited to do it was we need a capstone program that says this is what you do with knowing how to do a regression analysis. This is how you don't just do testing because you know how to do testing. It has a reason. Those kind of things. So we don't teach that. So this is a class that we want to have. But how's it all put together? Like, good. I don't have to use formulas, right? And I'm like, yeah, that's good. And so I enjoyed doing that, but I got pushback on a good number of students going, well, I can't just read the book and pass the test. No, you actually have to think. You're going to get scenarios that are like nothing you've ever seen before. That even if you work in industry, these are weird scenarios, and there's no right answer. And I got pushback from a good number of students going, "What do you mean there's no right answer?" I says, "What I want to see is that you actually think about it and can articulate it." And that threw a good number off their game. And like, well, wait till you get your first job. And I've run into PhDs and present company accepted, of course, is that they come in with, well, you have to call me doctor. And I'm like, no, I don't. I call you shithead, for all I care. But unless you're useful, can use your knowledge to the benefit of this group or this team or this product or our customers, then you're pretty worthless. And they didn't care for that at all. Well, I didn't spend 30 years in school trying to learn all this stuff. And for you to tell me that, I'm like, well, prove it. Do something useful.
Yeah, and you know that in many of my webinars and courses, I have enemies of reliability engineering. One of them is a ponderous professor.
Yep.
Who is who you're talking about. It's,
yeah.
Gets in the way.
There's that. And I think and it goes back to like many of our discussions is, well, what are you trying to achieve? If it's to be exposed to a wider range of techniques and methods and tools and a more deeper understanding, using my best English, a more better understanding of statistics, for example, then then yeah, and an in-depth, 3 or 4 year program of really diving into all the nuts and bolts and stuff is great. If you're able to use it, right? It's not just that you pass the course. What I ran into, and I did this in high school and undergrad, it's if you're a student that's to pass the test to get the degree, and you never use it again and never intend to use any of that knowledge again, then don't waste your time or your money or anybody else's effort and time and support and everything else. Don't go that way. If you're genuinely interested in really understanding, the mechanisms of, say, the log normal distribution, then yeah, and being exposed to lots of other stuff that you're willing to apply as needed. And I think the other piece of it is that you are not, if you have the attitude of once I get out of school, I never have to open a book again. And like, well, then you've just lost. It's our world is coming up with new materials, new environments, new challenges every day. And if you stop learning, you're going to be outdated and very quickly. So I think hallmark of a good reliability engineer with or without a degree is they're curious and they're willing to roll up their sleeves and go learn again and apply what they know effectively. It's not, I have this knowledge, therefore you must do what I say. I don't think it works that way.
Right, and that's one of the things that university sort of teaches, sort of status of seniority, and it is often a wake up call for PhDs when they can't get a job afterwards, or they can only get a job and they stay at a certain level within an organization until there's downsizing. And it's just you come across these people all the time who are just there for the sake of being there in organizations. Yes, they will rubber stamp reports and things like that, but no one seriously seeks them out. And I think when it comes to understanding what it is that PhDs can and can't offer, essentially when it comes to reliability and quality, it's a mindset. When it comes to design and development, it's as opposed to rushing to build the wrong thing fast, what you want to do is just carefully, methodically, and what might still feel like a painstaking amount of time, harness your corporate knowledge to make sure your first design's a reliable design, your first process is a high quality process. And that often involves nuggets of gold, corporate experience, facilitation skills, leadership to make sure everyone's heard and everyone's their 2 cents in, but also making sure that we make it clear that this is not supposed to be exhaustive. We're not trying to prevent every single problem. We're here to prevent the vital few, and we'll sit down and spend a bit of time working out what those vital few are, et cetera, et cetera, et cetera. I mean, PhDs study crack development in fatigue of alloys and things like that. A good designer just wants to know what the endurance limit is to make sure all stresses that metal experiences below that endurance limit, so fatigue never happens. That's one of the key differences.
Yeah, the early in my career, there was a PhD was hired into the team, and I worked in a factory that we made heating cables. It was a polymer extrusion process, and it is how we created our products. So we were using all kinds of weird polymers and exotic polymers and stuff like that to achieve the various temperatures we wanted to do. And my understanding of polymers, even after a year in that job, was that the stuff used for a switch plate is fundamentally different than the stuff we're using, because the switch plate doesn't bend very much, and if it bend it too much, it cracks and falls apart. Whereas this cable we're making is a softer thing, and I can bend it and twist it and do all kinds of stuff with it, and it doesn't break. It doesn't snap. The thermoset versus polymers. It had different names for different things. And that was about the extent of my knowledge of this stuff. And so this PhD joined our group, and we're a bunch of manufacturing engineers. And so one of the first tasks he had was to teach the rest of us polymer science. So some of it was naming things and identifying it, but it also went into, how the chain length mattered and why that mattered, what chain scissioning was, which was a function of how our product worked, and started to fail. And so when I ended up getting tasked with doing an accelerated life test, he was the first person I went to talk to, because he could explain to me what was this degradation mechanism that we knew was oxidation? How did that actually work? And how do I measure it in a meaningful way? And those kinds of questions. And I had a lot of great discussions with him, but it was help me understand that failure mechanism in a way that it probably would have taken me a year of it being in the library to figure it out. And at that point, he was like, wow, you learned this way back when, in school? And goes, yep. And so he was very proud of that. And I was very happy that he could help me. And so I had a favorable impression of him finally, but because a handful of others I ran across in different parts of the company were not so helpful or useful.
Yep.
But it was, and then he would check in, we're looking at the measurements and doing stuff we're doing. And he says, there's something else going on here. That curve should not be a curve. If the theory is right, that should be a straight line. And he says, well, there's a famous quote about, the theory is perfect until it hits reality or something like that. And so we both walked over and talked to a chemist in the group and says, how can we measure why this is behaving differently at the surface versus the internal? And it was the chemist's idea. Well, we'll shave it down and then we'll do an analysis of the properties of different layers across this material in the bulk. The theory is good if the bulk entirety is all behaving exactly the same way. But once it starts behaving differently, then the theory goes away. There's something else going on. And that led to a pretty useful discovery. But it was part behaving like a curious kid that was, what's going on here? How can I deal with this? Which has served me really, really well. And I think it would have done well in any industry or any discipline. I didn't need a PhD for that. And I unfortunately, for some folks, it's the mindset going in and what you're going to do with it and why you need it. If it's simply a resume stamp, that is a valuable thing to do, depending on where you work. I think you said that well, Chris. But if you want to actually make a mark in the industry or do well in your organization and be recognized as, a go-to type person to help solve problems, then that curiosity part and continuing to learn doesn't stop once you get your diploma mounted on the wall.
I agree. And I think the other thing that happens too, a lot of PhD guys, just because that's what the universities teach. Mostly when I did mine, I did it after I'd sort of done a few other things in my career. Mm-hmm. So this was, in fact, I was doing my PhD as sort of respite from another busy career. Didn't have a lot of expectations going in, but here I am. And I think that served me well. I mean, I had worked in environments where you have some incredibly smart people that really can't write English very well. So that's okay. I mean, they're the sort of people I want to fix my truck when, in less than 30 minutes with, bad things happening around you. They're the ones who are able to hang upside down through listening to the truck and doing all sorts of other things, just know exactly what needs to happen. And you can't test for that sort of stuff. And they might genuinely suck at many other things that we often describe as sort of Mensa level attributes of people who are intelligent, but they have intelligence that is just not sort of super academic. That's cool. I want those guys on my team more often than not.
Yep.
But I think PhDs, they just get taught that you are the apex. I don't think universities even try to teach PhD graduates their role in the world. And that's mainly because the professors don't know what their role in the world is either. They get frustrated when people don't listen to them and say, well, you took 65 minutes to describe the journey to your amazing discovery, and we haven't got the amazing discovery yet. It's that bad.
Yeah, you've described some pretty bad ones, and I've run into a few of them over my years. Geez, yeah, no, that's a whole nother episode. How did we survive that class? Kind of thing. But it's it's a similar discussion that people ask me is getting a ASQ CRE certification worth it? I said, if you want to learn a broader brush of what reliability engineering and the various methods in areas that you don't already have a mastery of, it exposes you, forces you to go learn about stuff that maybe aren't in your day-to-day job, the stuff you're doing now. So you can broaden your skill set slightly. And it does take discipline and some study and so on to do that. And other people, they have a great wealth of knowledge in the areas that are key to the getting that certificate, passing that test. And it's a marker. It's a milestone for some people, and it's a resume thing for some, and it's a personal pride. One of the things that came out of my looking at the survey results that ASQ would do is they would say, all right, well, if you get a certificate, you get paid more. And I challenged that premise that having the certification or having the degree, it is an indicator that you're going to get paid more. And is that because they got the certification? And then, so when I got my certifications, I did not get a pay raise. It was kind of bummed. This is boss. I got my certification. I'm supposed to make more money. Here's the pay scale thing. He goes, no, you actually have to use that information to show that you're more valuable. Oh, damn it. I thought it would be easy. I was giving him a hard time.
No, I mean, I know you're being a little bit more deep than that, but I know you don't get the CRE and automatically get a pay raise from your employer. However, I think the CRE is tremendously valuable if you're trying to compete for a job, and the job you're going for essentially involves people looking at your life on pieces of paper.
Yeah,
a CRE is very helpful when you're trying to be. It's not perfect. I'm not saying it is, but it's sort of the only differentiator out there in the world of reliability engineering, which is not a university degree, that shows that you've got some reliability engineering understanding. What you're actually taught in the CRE and the level of rubbish it entails is a different story. But it's not going to be. There are so many better courses to do. If you're already in an organization, you're not trying to secure a job, but you're trying to do your current job better and demonstrate value to your organization for that hypothetical debate you're going to have about how much money you should be paid. Mm-hmm. CRE is not the course for you. The CRE course to prepare you for the CRE certification is not the route you should follow. But if you're trying to get a job or a better job, I think a strong case could be made.
Yeah. And it's the attitude, I think. It's not the end game. It's what you do with the knowledge and what you do with the ability to use that knowledge that matters. And there's plenty of folks that do really, really well. They become the fellow in their organization, independent of what their educational degree is because they do the equivalent of doing all that work for the CRE or for a PhD and everything else, but they do it day in and day out and regularly, effectively apply their knowledge to make a difference. So we found it, even though we should have just stopped recording after no. Well, I agree with it. It depends. And there are nuances to it. And I think it goes almost always to mindset and how you apply yourself.
Absolutely. And Madame Curie didn't have a chemical engineering degree. She also poisoned herself with radiation, but
yeah.
But no, she was just a genius. That's all she was.
Yeah. Imagine what she would have done if she would have lived for another 20, 30 years. It's from what I saw in a biography, she was working on all kinds of cool stuff when she was failing from the poisoning. But it's like, bummer. Anyway, that's a subject for a whole other podcast, I guess. But anyway, if you're listening to this, if you're contemplating getting a degree or a certificate or stuff like that, did we clear that up at all or just muddy the waters a whole lot for you? So let us know. And maybe you got the pay raise after you got your degree. That'd be cool to hear about how that actually laid out and worked. But education is not bad in and of itself. Learning and being curious and figuring stuff out is great. If a certificate or a degree is something that you would find value in and of just for yourself, go for it. At the end of the day, you need to be useful. and add value in what you do. So if you got any questions about that, let us know. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. You can also find us, Chris and I and the other hosts of the show are available through LinkedIn and our About pages. I should also do a plug just for the stuff that's on Ascendo. If you want to learn something, there's a lot of stuff there that you can learn from. And if you want to contribute, that's even better. So anyway, thanks, Chris, for putting up with the assault on the value of PhDs. But I think we pretty much agree on how that all should work anyway.
Yeah. Yeah, unfortunately, I've met quite a few of them, so
Yeah.
I'm very well informed.
That's right. Yeah, same. All right, great. Thanks so much, Chris. We'll talk to you soon.
Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.